afternoon, all of you. Am I audible? Yes. Good afternoon, online class. Kundan, Sandeep, Abhinav, Poonam, Prashant, Srimati, Sneha, Shagun, and all others. Right. So we've completed the part of the physical geography, the landscape geography. When I say landscape, we've understood about the formation of. We've understood about the types of mountains, cold mountains, block mountains, Rift Valley. Term samajh aa rahe hain? The Rift Valley and the other things. You understand about the geological timescale and the landform formation. We went on to understanding the processes that shape the landform, the endogenic processes and the exogenic processes. Endogenic and exogenic, we've done that. Last class mein gayab the endo exo ke. ठीक है. So now let's start off with the climate part. When I say climate, what are the elements of climate? Tell me, what are the elements of climate? जब आप climate बोलते हो, आप किस elements की बात करते हो? किस parameters की बात करते हो? What are the parameters that you think of? Temperature, pressure, precipitation, temperature, pressure, precipitation, altitude, physical वाला हो गया. Humidity, okay. Humidity और पानी नहीं आया था, पानी ज्यादा आ गया था. Precipitation, rainfall, precipitation, right? One type is rainfall, the other type is snowfall, the other type can be drizzle. Winds, talk about winds. Or somebody said atmosphere, or wind flow, humidity. Follow. Ocean. Atmosphere. Atmosphere का temperature, atmosphere का density, atmosphere का composition. Vegetation is linked to climate, ठीक है? It is linked to climate, but it is not an element of climate. No, it can indicate a climate. Extreme events, cyclones, extreme events like cyclone, like cloudburst, or floods. ठीक है? Excessive rainfall leading to floods, linked to climate. The climate and weather. Heat waves, very good. Heat wave, cold waves. The extreme events. This is what is climate. Why am I making you do this? Because if you look at the questions that have been asked in the climate related aspects, if you look at the questions in your mains examination, one question is, let's say that what are the arrangement of the mountains in the world? And how do the arrangements of the mountains? Now you understand the arrangement of mountains. You know Rockies, you know Andes, you understand Alps, Himalayas, pata hai. I hope you know Great Dividing Range. You understand the east side of Australia, north-south. This is my Australia here on the east side. The north-south orientation is your Great Dividing Range. The question has been, how does the orientation of mountains affect the climate of a place? What is climate then? You should at least know how does the orientation affects the temperature. If I say Himalayas, they actually affect the temperature of my country. How? They stop the cold Siberian wind. So the arrangement of the mountains affecting the climate, How does Himalaya affect the pressure? It is related to Himalayas. You will see that the monsoon wind, whether the monsoon will come in India or not, also depends on the pressure affected by Himalayas. Whether there will be western disturbances, rainfall in winters, also because of the cyclonic pressure, cyclonic rainfall got by the Himalayas. So you should know what are the elements of climate. Questions जो mains में पूछता है, उसमें आपको पूछता है इस चीज का इफेक्ट ऑन द क्लाइमेट, दिस थिंग क्लाइमेट, this thing climate. So at least you should know what are we going to study in climate. We are going to start off with atmosphere. We'll start off with composition of atmosphere. Then we'll move on to greenhouse gas, then heat budget, and then the other parameters. ठीक है, तो आपको at least कहीं आप लिख लें the elements of climate. If you have not written, write the elements of climate. Just make a hub spoke diagram so that at least you'll know कि climate यानी क्या. What do we mean by climate? ठीक है. So we'll start off with what are the elements of climate. The elements of climate are atmosphere, composition, layering, atmosphere, the composition and the temperature, density, composition, layering, temperature, composition of the atmosphere, the layering of the atmosphere. Layers हैं हमारे atmosphere में. What are the layers? Mesosphere and thermosphere, right? Troposphere, stratosphere, mesosphere, and thermosphere. So the first thing we'll study is atmosphere, composition, temperature, heating, the layering part. Then write about the various elements: temperature, pressure, humidity, right? Precipitation. Precipitation can be of various types: rainfall, snowfall, hailstone, drizzle. Talk about winds. कौन सी winds के बारे में सुना है? Name some winds. Sea wind, हाँ? Trade winds or westerlies, polar easterlies, seasonal winds like monsoon winds. Chinook का नाम सुना है? Chinook, Pon, ठीक है? So winds, some name that you can remember. Extreme events, the extreme events like cyclone, cloudburst, heat waves, cold waves. Online class with me? Okay. So let's start off with the first topic, that is atmosphere. That is the atmosphere. Right? What is atmosphere? What is atmosphere? A blanket of the gases, a blanket of gas that surrounds the Earth. Atmosphere is the blanket of gas that surrounds the Earth. It is composed of gases, dust particles, water vapor, pollutants, ions of hydrogen, oxygen, nitrogen, helium, जो ionic form में है, split हो चुके हैं. Hydrogen is split, it is in ionic form. Oxygen has split, it is in the ionic form. ठीक है? So in these are also found in your atmosphere. It is these ions that interact with the solar winds. ठीक है? It is these ions that interact with the solar winds. Okay. So this is atmosphere. What is the composition of atmosphere? What is the composition of atmosphere? I know you know it. Composition of atmosphere. Nitrogen, how much percentage? 78%. What about oxygen? 21%. 78% nitrogen, 21% oxygen. then 0.93% argon, 0.03% carbon dioxide. So you have nitrogen, you have oxygen, argon, carbon dioxide, and trace gases of hydrogen and helium. Trace gases of hydrogen and helium. लिखो क्यों नहीं लिख रहे हो? I'll sort of dictate separately again. My handwriting is also not beautiful to see, so we'll write. It's not as beautiful. Online class, I hope you are writing. What is ionic form? Split kiya hua hai. For example, oxygen is like this. That can be split into oxygen atoms. Okay. So splitting into atomic form, the ionic form. That is your. So nitrogen does not exist. In the nitrogen exists in to some extent. This is my atmospheric layer. To some extent, let's say up to 80 kilometer, I can have nitrogen in the gaseous form. But above 80 kilometer, I can have nitrogen atoms split. Okay, that is our ionic form. CO2 के बाद क्या लिखा है? 0.93% is argon. 0.93% is argon. 78% is nitrogen. 21% is oxygen. Carbon dioxide is 0.03%. There are trace gases of hydrogen and helium. Trace gases of hydrogen and helium. Is it fine? Karthike, is it fine? Priya? Acha, okay. Oh. Background change करना. This is fine? Or you want some other color? Lucky, ठीक है? Dark green. This one. This one. This one's better. Deep is fine. Is it fine? Hydrogen and helium. Thank God, मुझे चाहता है change करने का ना. Fine. Okay. सबसे पहले जीवन में करियर की स्टार्टिंग में बोर्ड ही सीखा था. I was in operations. My journey started with operations after UPSC. Obviously, I started working in operations. कैसे डालते हैं, कैसे PPT डालते हैं, कैसे बोर्ड का कलर चेंज करते हैं, कैसे पेन का कलर चेंज करते हैं. So I am not handicapped there. Thank God. ठीक है. So we are talking about the elements of climate. It starts off with atmosphere. We move on to the extreme events, climate change, the processes involved, and then the climate classification. This is something that is there in your NCERT in the form of Köppen's classification. Okay. So what is atmosphere? Atmosphere is nothing but a blanket of gas that surrounds the Earth. This blanket of gas has hydrogen, helium, and other things. What is the composition? The composition is 78% nitrogen, 21% of oxygen, then 0.93% of argon. You have hydrogen, helium, water vapor bhi likh lo. I believe you've not written water vapor. Water vapor. Okay. Okay. Now, one interesting story before we start off. One interesting story. Okay. Here. Can somebody throw light? If you remember the first few classes, can somebody throw light? This is my sun. Okay. Taking two planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Okay. So what are these called as? Inner planet, terrestrial planet, rocky planet. What are these called as? Outer planet, Jovian planet, Jupiter-like gaseous planet. If I talk about Venus, does somebody remember the atmosphere? Did I tell you about the gases, the atmospheric gases? It has what? 95 to 96% of carbon dioxide. What about Mars? Mars also has 95 to 96% of carbon dioxide. हमारे यहाँ पे कितना carbon dioxide है? Trace gases 0.03, but they have 95 to 96% of carbon dioxide. What about these outer planet? What are their atmosphere composed of? Hydrogen and helium. Why is my atmosphere so unique? Why is my atmosphere so unique? ऐसा नहीं है कि यहाँ नाइट्रोजन नहीं है, वीनस में भी नाइट्रोजन, मतलब अमोनिया है, अमोनिया की क्लाउड्स हैं, अमोनिया है, नाइट्रोजन वहां पे भी है, but then why is my atmosphere so unique? What happened? Why I don't have hydrogen and helium? Why I don't have as much of hydrogen and helium? Jupiter, 90% hydrogen and helium. You remember that? It is nearer to the sun. So what will happen? Can the gases condense to solid particles? The gases have not condensed. They have not turned into solid particles. So it is near to sun. The gases have not condensed. They were in the gaseous forms. Because it is near to sun, there were solar winds. There were solar winds. So what happened? The hydrogen and helium were blown off. Why did the earth not hold them then? It could have held them. Earth is small, so it does not have as much of gravity. इतना तो समझ आ गया कि इनर प्लैनेट में हाइड्रोजन और हीलियम क्यों है या क्यों नहीं है. Why don't they have hydrogen and helium? The first lecture, there were three factors. They are very small. They cannot hold the light gases. Solar wind blew off the gases, and because it is very hot, they could not condense. They could not turn into solid particles. Therefore, you don't have hydrogen and helium. They have hydrogen and helium. What about argon? What about carbon dioxide? Why is only carbon dioxide 0.03%? When Venus and Mercury, Venus and Mars, they have 96% of carbon dioxide. Because it got, let's first understand argon or oxygen or ये आया कहाँ से? Carbon dioxide आया कहाँ से? When the Earth was in nebula phase, it was cooling and contracting. So there was degassing. So there was lot of carbon dioxide, lot of argon that has come. So therefore, the same thing happened with Mercury, Venus, and Mars also. Degassing, cooling, lot of carbon dioxide is coming and forming a part of atmosphere. But because my Earth is at a suitable distance, Earth is at a suitable distance from the sun. So what I have? I also have water droplet. Water can exist in the liquid form. So what is happening? As there is degassing happening, the air is coming, the gases are coming, the gases are rising, water vapor is also rising. Water vapor is, as it rises up to a certain limit, what will happen? It will cool. The water vapor will cool and will come down in the form of rainfall. So what will happen? As it is coming down in the form of rainfall, it is dissolving what? It is dissolving carbon dioxide. And therefore, after dissolution of carbon dioxide, what is happening? After dissolution of carbon dioxide, it becomes a part of the ocean water. So carbon dioxide plus ocean water is there in your ocean basins. Ocean के जो depressions है, वहाँ पे carbon dioxide dissolve हो गया. सारे में ही यही हुआ that the nebula was cooling and contracting, and the gases were coming. So even Earth had lot of carbon dioxide, like Mercury and like Venus and Mars. Like Venus and Mars, Earth also had lot of carbon dioxide. Venus or Mars में जैसे carbon dioxide. But what happened with Earth? With Earth, because it is at a suitable distance, water can exist in a droplet form. So as there is degassing that is going on, there is dissolution of carbon dioxide in the water, and then that pours down to become a part of the ocean basins. So why don't we have as much of carbon dioxide, unlike the Mars and Venus? Because our carbon dioxide has been dissolved in the water and it has fallen into the ocean basins. So हमारे पास क्या है? 0.03% of the carbon dioxide. What about the nitrogen? सबसे important, 78% of nitrogen. Yes, ammonia was also there. So what happened to ammonia was there was degassing. When there was degassing, ammonia was also there. But then the ammonia was split by the NH3. Ammonia was there, NH3 got split by the UV rays. It converted into nitrogen and it converted into hydrogen. Hydrogen, again being the light gas, it got escaped. Nitrogen kept on building. Nitrogen build hota chala gaya. Nitrogen is not a very reactive gas. So it does not react as much and it kept on building. So what do we have? We have 78% of nitrogen. And एक बार oceans बन गए, oceans में life आई. blue-green bacteria, blue-green algae and the bacteria, they start using the carbon dioxide, and then there was evolution of plants also. They start using the carbon dioxide and they saturate the ocean water with oxygen first. Once the ocean water is saturated with oxygen, oxygen becomes part of the atmosphere. Oxygen कैसे आया? Nitrogen समझ गया, hydrogen समझ गया, carbon dioxide भी समझ गया. What about oxygen? Because you have oceans, the life evolved. As plants evolve, carbon dioxide is being taken from the ocean and oxygen is being given into the oceans. Once the ocean water is saturated with the oxygen becomes a part of your atmosphere. So now I understand the story of nitrogen. I understand the story of oxygen. I understand the story of carbon dioxide. I also understand the story of hydrogen and helium. This is given in your chapter 2, the evolution of atmosphere. We talk about वहाँ पे evolution of atmosphere. There's only one paragraph that is given. बहुत सारी चीजें नहीं बोली हुई है. नाइट्रोजन की बात नहीं बताई हुई है. हाइड्रोजन और ऑक्सीजन की ही बताई हुई है. They don't tell us about the story of nitrogen. They don't tell us about the story of carbon dioxide. Okay, so this is the whole story there. You write it down, then we'll see. Okay, online class, I hope you are there. Okay, so write the first, the evolution of atmosphere, formation of atmosphere. Okay, first, the stages in the evolution of atmosphere. Are first, Earth being a hot nebula, Earth being a hot nebula, Earth being a hot nebula with primordial atmosphere. Primordial, मतलब ancient, initial, primordial atmosphere. Okay, primordial atmosphere composed of hydrogen and helium. Composed of hydrogen and helium. The Earth is a hot nebula, and it has what? It has primordial atmosphere. The atmosphere is what? Hydrogen and helium. Okay, first stage. Then what is happening? The second stage. Go to the second stage. The second stage is loss of the primordial atmosphere. Loss of the primordial atmosphere. Because of the effect of the solar winds. Because of the effect of the solar winds. Okay, so initially there was primordial atmosphere, then this primordial atmosphere was lost, hydrogen and helium was lost because of solar winds. At the third stage, the degassing stage. The degassing stage. The degassing stage and the release of carbon dioxide, water vapor, and ammonia. There's release of carbon dioxide, water vapor, and the ammonia. Right, the third stage, where there's degassing stage, where water vapor is getting released from the interior of the Earth, carbon dioxide is being released from the interior of Earth, and ammonia is being released from the interior of the Earth. So the third stage. This was the third stage. Right, the fourth stage. The cycle of evaporation. The cycle of evaporation. Like cooling of water vapor, evaporation of water vapor, cooling of water vapor, condensation, changing of water vapor into water droplet, condensation, and precipitation, Okay, what is happening? Water vapor is evaporating. As it is evaporating, it is cooling. As it is cooling, it is condensing. Conversion of water vapor into water droplet. And then there is precipitation. And it's not just one process. There is a cycle that is going on. Evaporation, cooling, condensation, precipitation. Evaporation, cooling, condensation, precipitation. The whole cycle goes on, right? So, right, there have been cycle. There are repeated cycle. Of evaporation. There are repeated cycle of evaporation and precipitation. Repeated cycle of evaporation and precipitation. Okay. In this process, the water vapor, the water droplet. In this process, the water droplet dissolves the carbon dioxide, which accumulate in the form of ocean waters. Okay. Therefore, other planets have more of carbon dioxide and our planet does not have as much of carbon dioxide in its atmosphere. दूसरे planet में ज़्यादा है, हमारे यहाँ पे नहीं है. क्यों है? ये reason. ठीक है. So write this. The next stage is about the story of ammonia. Ammonia gets struck by UV rays. Ammonia gets struck by UV rays to split into nitrogen and hydrogen. Hydrogen gas evaporates. While nitrogen continues to build up. Therefore, there is what? Accumulation of nitrogen, क्योंकि build up कर रहा है. It's not a very reactive gas. It keep on building. What happens in the ocean then, right? The stage of formation of oxygen. And next stage, the last stage, the stage of formation of oxygen. In the oceans, with the formation of life, like cyanobacteria. Carbon dioxide is utilized. And oxygen is released as byproduct. Once the ocean water is saturated, as byproduct, once the ocean water is saturated as a byproduct, once the ocean water is saturated with oxygen, oxygen becomes a part of atmosphere. oxygen becomes a part of the atmosphere. Okay, this is how your atmosphere has evolved. That from one part to the from one to another. Okay. Yes. They have nitrogen. They have nitrogen. They have nitrogen, build-up of nitrogen. Mercury पे इतना नहीं है because it is very near to sun. Intense solar waves, solar winds. They do not have as much of atmosphere only for that matter. Venus has lot of atmosphere. It has lot of carbon dioxide, and therefore it is also the hottest one also. ठीक. Somewhat. हाँ, respiration के लिए भी oxygen use होगा. हाँ. Very limited amount, not as high as 21%. Degassing हुआ है तो ऑक्सीजन भी आएगा, but इतना नहीं. ठीक है, थोड़ा बहुत, very less. It is because of this process that you have much of the oxygen. ठीक है. Okay. So what are we referring to? We are referring to the composition and the evolution of the atmosphere in the earth. If I give observation, if I give you some of the observation, one of the observation here is 98%, sorry, 78% of nitrogen, 21% of oxygen. Both of these gases directly, in the way they are present in the Earth's atmosphere, they don't directly they don't act like a greenhouse gas. Okay. What is a greenhouse gas? Greenhouse gases, pata hai? Do we know greenhouse gases? Some examples you might be hearing in the newspapers also. Carbon dioxide, methane, some of the nitrous oxides. Right? Yes. So these are your greenhouse gases. What do these greenhouse gases do? They trap the heat. The heat that is trapped in the atmosphere is there because of the greenhouse gas. If I look at my composition of atmosphere, one fact that I should appreciate is nitrogen and oxygen, right? They do not directly, in the way they are present, act as a greenhouse gas. So only 1% or less than 1% of Earth's atmosphere is actually directly taking place in the form of greenhouse gases, like water vapor, like carbon dioxide. Carbon dioxide is what? 0.03%. What about the water vapor? There is variation in the water vapor, 1% to 4%. So less than, in reality, if you look at less than 5% or less than 1% of the gases, they actually indulge in the greenhouse gases. And we are so concerned. Imagine, agar baki sari bhi participate karti directly, then what would the temperature of the Earth be? Okay. This is one thing that you can say. Please write nitrogen and oxygen. Nitrogen and oxygen. Nitrogen, oxygen, and argon. Nitrogen, oxygen, and argon do not. Nitrogen, oxygen, and argon do not directly play an important role in the various climatic processes like wind, like rainfall, as they are not greenhouse gases. The greenhouse gases are those that absorb the heat, like carbon dioxide, methane, ozone, etc. Okay. These are the one, they are playing an important role in the heating of the atmosphere, in the keeping your Earth warm, right? Just 0.1% or even less than 1% of the Earth's atmosphere. Now, if I talk about the atmosphere, what is atmosphere? I said atmosphere is nothing but a blanket of gas. Now, I want to study this blanket of gas because it is this that plays a very important role in the climate. It is this that plays a very important role in warming of the earth. So if I have to study this atmosphere, I can study the atmosphere into various layers. I can study the atmosphere into various layers. One classification that you know is troposphere, stratosphere, mesosphere, and thermosphere. ये आप layering कर रहे हो atmosphere को, किसके basis पे layering कर रहे हो? What is the basis of this? What is the basis of this layering? This is, let's say, your Earth's surface. This is the atmosphere. I am layering the Earth's atmosphere into, I'll just draw like this, troposphere, stratosphere, mesosphere, and thermosphere. किस बेसिस पे आपने बोला ये थर्मोस्फेयर है, ये स्ट्रेटोस्फेयर है, ये मेसोस्फेयर है, ये थर्मोस्फेयर? On the basis of density of gases? No. Composition of gases? No. On the basis of temperature? Partially correct. Temperature pattern. On the basis of, not on the basis of temperature, but on the basis of temperature pattern. What is the temperature pattern? That as you go up to troposphere, the temperature decreases with the increase in the altitude. The temperature increases with the increase in the altitude in the stratosphere. The temperature again decreases with the increase in the altitude in the mesosphere. The temperature keeps on increasing as you go with the higher altitude in the thermosphere. So जो आप layering की बात करते हो, आप बात करते हो temperature pattern पे, not on the basis of density, not on the basis of composition. One is that the temperature decreases with the increase in the height. The temperature increases with the increase in the height. The temperature decreases with the increase in the height. The temperature increases with the increase in the height. This is a pattern that we have observed and we are doing the layering. Right? There are other patterns also in which you can layer. There can be 3 patterns in which you can layer your atmosphere. One, on the basis of relative mixing. If they are mixing or not. That is what composition is. कि mix हो रहा है कि नहीं हो रहा है. I can also have a layering on the basis of density. It is not TSMT. It is not troposphere, stratosphere, mesosphere, thermosphere. It is not that. And I can also have on the basis of the temperature pattern. What you know is this. What we also need to know is these two. Why we need to know these two? Because if you want to understand various phenomena of weather, you also need to know these two parameters. So give the heading, layering of the atmosphere. The layering of the atmosphere. It refers to the structure in the way atmosphere is organized. In the way atmosphere is organized. And how the layers in the atmosphere are arranged. Okay. There can be three ways of layering. There can be 3 ways of layering. One, on the basis of temperature pattern. On the basis of temperature pattern. जो आपको पता है, troposphere, stratosphere, mesosphere, and thermosphere. That is first one. Second, on the basis of relative mixing. On the basis of relative mixing. And the third, on the basis of density. On the basis of density. Okay. So let us understand each one of them one by one. When I say on the basis of density, this is how your atmosphere actually looks like. The atmosphere, this is your atmosphere. In the atmosphere, what do you have? The blanket of the gases. You have air molecules. So if I look at your atmosphere, much of the gases, like compressible, this is a gas. The whole of the gas, nitrogen, oxygen, ये सब है. They can be compressed. They can compressed into one layer. Why is this compression taking place? Because of gravity. So gravity is acting and the atmosphere gets compressed. So what happens because of compression? This is there are more air molecules near the surface, near the Earth's surface. As you move away from the Earth's surface, there are less air molecules. Further, less air molecules. As you move further up, there are very less air molecules. So if I look at my atmosphere, yes, the atmosphere can extend up to thousands of kilometers. But 99% of atmosphere is within this 80 kilometers. Within 80 kilometers, you have what? 99% of the atmosphere. Atmosphere hai kab tak? Thousands of kilometers tak, but much of the atmosphere is in what? Is in the lower layers. So which has the most density if I ask you? Troposphere, mesosphere, stratosphere, thermosphere. Which has the most dense? Troposphere. Okay. This is on the basis of the density. I'm not writing troposphere here. I'm just making you understand that on the basis of density, much of the atmosphere is what? Is within 15 kilometers, 50 kilometers and 80 kilometers. Okay. So first one, the atmospheric layering. The atmospheric layering on the basis of density. The atmospheric layering on the basis of density. Right? The atmosphere has weight. The atmosphere has, first one, the atmosphere has weight and is compressible. And is compressible. Nearly 50% of atmosphere, nearly 50% of atmosphere is within 5.6 kilometer. Is within the 5.6 kilometer. Here, to look at here. To look at here. So if you look at here, this one, this is on one side, I am writing the pressure in millibar. On one side, we are writing the altitude. We'll draw this, listen first. So if you say 50% of atmosphere is within 5.6 kilometer, so can I have, if the atmospheric pressure on the surface, if the atmospheric pressure on the surface is, let's say, 1000 millibar. If I move up, this is my surface, here the pressure is what? 1000 millibar. And I say 50% of the atmosphere is like here, and 50% of the atmosphere is up. This is what? 5.6 kilometer. आप यहाँ पे खड़े हो तो आप पे 1000 MB का pressure feel हो रहा है. Standing here, right now I can feel, let's say I'm at the sea surface, I can feel thousands MB of pressure upon me because, or from all the sides for that matter, because there is atmosphere that is exercising pressure. If I move at a higher altitude, I have kept 50% of atmosphere below because 50% यहाँ पे रह गया, and this is, let's say, 5.6. 50% of atmosphere will be above me. 50% of atmosphere will be below me. Let's say this is the sea surface that I'm standing, and this is 5.6 kilometer. If I'm standing here, 50% of atmosphere यहाँ पे और 50% atmosphere ऊपर है, तो मुझे how much pressure will I have? 500 MB. If I further move, let's say at 10 kilometer, I have 90% of the atmosphere below. If I'm standing here, what is the pressure that I will experience? 100 MB. Why? Because 900 MB to niche chhut gaya. So as you move higher in the altitude, have you seen that we witness the blood from the nose? Why? Because my body is used to a pressure at a sea surface. If I go above, at say top of Himalayas, the atmospheric pressure is very less, but my body pressure is very high. So what happened? The nose starts bleeding. So why does the nose start bleeding as you move up higher in the altitude? Is because the atmospheric pressure has fallen. Why has the atmospheric pressure fallen? Because much of the air molecules are below. So what I'm saying at 5.6 kilometer, 50% of atmosphere is there. Right, the next point, we'll draw this at 16 kilometer. At 16 kilometer, 90% of, at 16 kilometer, 90% of atmosphere is within the 16 kilometer. 90% of atmosphere is within 16 kilometers. Right, the third one, 99% of atmosphere. 99% of atmosphere is within, 99% of atmosphere is within 50 kilometers, 30 kilometers, sorry, 30 kilometers is within 30 kilometers. 99% of atmosphere is within 30 kilometers. So within 5.6, you have 50%. Within the 16 kilometers, 90%. मतलब Himalaya को double कर दो. Himalaya is 8 kilometers, double of Himalayas. 90% of the atmosphere is over. If I further go up, again at 30 kilometers, 99% of atmosphere is there. In case you know the relation, in case you know some, this one. You know your troposphere, right? The troposphere extends up to what kilometer, anybody? 8 to 13, 8 to 18. 8 to 18. It is at poles, it is 8 kilometers. It is at equator, it is 18 kilometers. This is troposphere. If I talk about stratosphere, it is up to 50 kilometers. If I talk about mesosphere, it is 80 kilometers. And this is what, on the basis of temperature pattern. If I superimpose my layering based, I am saying that by 30 kilometers, what do you have? By 30 kilometers, you have 99% of the atmosphere. 99% of atmosphere is within 30 kilometers. तो ऊपर कितना कम air molecule होगा? और भी कम air molecule होगा. This is why, because the atmosphere has weight and it is compressible. Much of the air molecules are near the surface. What you do is draw this diagram. समझ आ रहा है? Online class, is it clear? Is it fine or not? Now diagram. This is trying to show what? This is trying to show altitude. This is trying to show pressure. This is 1000. This is up to 630 kilometers. It is maybe what? 100 MB. Within 5.6 kilometers, we have 50%. This is, let's say, at 5.6 kilometers. Within 16 kilometers, you have 100 MB. And within 30 kilometers, you have just have 10. Drastically pressure fall होता है. Your pressure starts falling drastically. All of you done? So ऐसे करवाएं क्या? That will be more visible, right? All of you done? Within mid of stratosphere, you will say 99% of atmosphere stratosphere के आधे टाइम तक ही आधे इसमें ही खत्म हो जाता है. Stratosphere extends up to 50 kilometers. Within 30 kilometers, you have 99% of the atmosphere. Right? If there are more of the gases at below, you will also have more of water vapor below. You will also have more of carbon dioxide below. You will have more of greenhouse gases below. So where should a greenhouse gas be more? If this is my surface, at 1 kilometer or at 3 kilometer. If the air molecules are more here, the greenhouse gases will also be more at 1 kilometer. As you move at 3 kilometer, there would be less greenhouse gases. Come greenhouse gases रहेंगे. ठीक है? Okay. Give the second one. The second layering on the basis of relative mixing. Layering on the basis of relative mixing. If I talk about why is this PPT working like this? Fine. Okay. Layering on the basis of the relative mixing. So if I see from the bottom up to top, up to 80 kilometers, right? अभी दूसरा पैटर्न ही पढ़ रहे हैं, दूसरी ही लेयरिंग समझ रहे हैं. लेयरिंग किस पे समझ रहे हैं? मिक्सिंग पे समझ रहे हैं, on the basis of relative mixing. So if I look at my atmosphere, it can go up to 1000 kilometers, that is fine, but up to 80 kilometers, it is well mixed. Like if you take up any packet from 80 kilometers, you will find what? 78% of nitrogen, 21% of oxygen, 0.93% of argon. You take it from here, you take it from here, you take it from here. Anywhere that you take, you will have nearly same composition of the gases. But as you move above 80 kilometers, the gases now start separating. They become into layers. The solar winds interact. They are now changing their form. They are not into one gas, whole one single gas. They are breaking. You will have a layer of nitrogen. You can have a layer of oxygen and oxygen molecules. You can have layer of nitrogen and nitrogen molecules. You can have layer of hydrogen and hydrogen molecules, helium and helium molecules. इसी को आप क्या बोलते हो? Ionosphere. Ion के फॉर्म में होता है, इसी को आप ionosphere बोलते हो. So up to 80 kilometers, you can say your atmosphere is what? Up to 80 kilometers, your atmosphere is, you're only like in plot. Up to 80 kilometers, my atmosphere is homosphere, one single sphere. Above 80 kilometers, the gases have separated into layered form based on the molecular weight. Nitrogen, nitrogenic atom and nitrogen gas. Oxygen and oxygen gas. Oxygen atom, oxygen ions. You have hydrogen ions. You have helium ions. This is what you call as ionosphere. तो बोलते हो ना स्ट्रेटोस्फीयर के ऊपर थर्मोस्फीयर में एक लेयर है called as ionosphere. What is this? This is your atmosphere is now breaking into various gases. Up to 80 kilometers, it is the homosphere. So give the heading on the basis of relative mixing. See, first point, much of the atmosphere is very well mixed, and despite being mixture of gases, and despite being mixture of gases, it acts as one single layer of gas. One single layer of gas. This is seen in first 80 kilometer. This is seen in the first 80 kilometer. It is called as homosphere. It's like your namkeen mixtures that you have. So it has various constituents, but then it is so well mixed that you pick up any handful of namkeen, you have almost the same constituents. You almost have the same constituents. That is what the atmosphere is so well mixed that despite having lot of gases, different gases, it is acting as what? It is acting as a unified gas. Okay. Above 80 kilometers, right? The next one, above 80 kilometer, the gases and ions, they separate out. Gases and ions, they separate out according to their weight. According to their weight. Molecular weight के हिसाब से they separate out. This is called as heterosphere. This is called as heterosphere. H-E-T-E-R-O, sphere. S-P-H-E-R-E. Heterosphere. Homo means single, homosphere, and heterosphere. Okay. You can write the lower layers have nitrogen molecules and nitrogen ion. Nitrogen molecules and nitrogen ion. Along with oxygen ion and oxygen molecules. While the upper layers have hydrogen and helium molecules. Hydrogen and helium molecules. Light है हाइड्रोजन और हीलियम तो वो टॉप में रहेंगे, हेवी होते हैं नाइट्रोजन और ऑक्सीजन तो वो बॉटम में रहेंगे. ठीक है. What happens is whenever any molecule they gain an extra electron or they lose an extra electron, atom और a gas, जब कोई extra electron आता है या कोई lose करते हैं तो कौन सा form बन जाता है? Ionic form. तो यहाँ पे they are charged. The sun, solar winds is interacting. It splits the gas and then they can either have an extra electron or they can lose the electron and they can become in the ionic form. सबसे ज़्यादा impact solar winds का thermosphere पे हो रहा है and therefore in the thermosphere there is a ionosphere. So up to 80 kilometers, troposphere, mesosphere, stratosphere, it is homosphere. In the thermosphere, it is your ionosphere. This is nothing but your ionosphere, right? Okay, this is this ionosphere which then interacts with your solar winds to produce what? To produce beautiful, colorful lights called as auroras. Aurora australis or aurora borealis. ये ions react करती हैं solar winds के साथ. ठीक है? So this is about your second one. The third one, you know, the layering of the atmosphere on the basis of temperature pattern. On the basis of your temperature pattern. The layers are Troposphere, stratosphere, mesosphere, and thermosphere. Troposphere, stratosphere, thermosphere, and mesosphere. ठीक है? Right? Just 1-2 words. Then we'll deal with detail in. We'll deal with layering in further more details. But write first 2-3 words. One. The temperature. The temperature increases with the increase in height. The temperature reduces with the increase in height. The temperature reduces with the increase in height in troposphere. I'll repeat first point. Temperature reduces with the increase in the height in troposphere. The temperature increases with the increase in height in stratosphere. The temperature reduces with the increase in height. Temperature reduces with the increase in height in mesosphere. And the temperature increases with the increase in the height in thermosphere and exosphere. In thermosphere and exosphere. ठीक? नहीं लिखा? क्या मिस हुआ बताओ? ये वाला टेम्परेचर वाला पूरा लिखने की जरूरत नहीं है, सिर्फ इतना लिख लो. Temperature, look at here. The temperature reduces with the increase in height in troposphere. Just write keywords. The temperature increases with the increase in height in stratosphere. The temperature reduces with the increase in height in mesosphere. And the temperature increases with the increase in height in thermosphere and exosphere. नहीं लिखा? लिख लिया? लिखाओ. अरे बाकी भी तो लिखो. T और H. अच्छा बाकी लिख लिया. ठीक. T and H and the layer. Done. तो ये है आपकी. But हो क्यों रहा है ऐसा? उसको समझने के लिए. Why is this happening? Why is the temperature reducing with the increase in height? Why is the temperature increasing with the increase in height? Why is the temperature again reducing? Why is the temperature again increasing? For you to understand, you need to understand the heating of the Earth's atmosphere. Earth's atmosphere and Earth. How does the atmosphere gets heated and how does the Earth gets heated? कैसे heating होता है? तो लिख लो. The heating and the heating mechanism. With the heading, the heating mechanism. Heating mechanism of the Earth and Earth's atmosphere. Of the Earth and Earth's atmosphere. This is the Earth surface. Heating of the Earth and Earth atmosphere. This is the Earth surface. This is the atmosphere. How does the atmosphere gets heated? And how does the Earth surface gets heated? So this is your sun. If the atmosphere would have been directly heated by the sun, then what should have happened? सबसे ज़्यादा temperature होता this point, उससे कम temperature होता at this point, उससे कम temperature होता at this point. Point C would be very, very hot. Point B would be lesser hot. And A would have been cooler. Why? As because it is heating directly by the solar radiation. But that is not, you see, on the basis of temperature pattern, what you can see, there is fall in the temperature, rise in the temperature, fall in the temperature, rise in the temperature. Why is this happening? Because when you talk about the sun does not directly heat the atmosphere. Sun directly atmosphere को heat नहीं करता. Sun heats what? Sun heats the Earth's surface. Sun heats the Earth's surface. Once the Earth's surface has absorbed the heat, The Earth's surface then radiates the heat, again gives back the heat. And who absorbs that heat? The absorption is by your atmosphere. So what if this is the heating source? What will happen? If this is the heating source, as you move away from the heating source, the temperature will go less. So this is the temperature profile. As you move away from the heating source, the temperature reduces. So if I have to show like this, away from the heating source, the temperature is getting reduced. This is the altitude. This is the temperature, right? Why is this happening? Because in your atmosphere, you have what? Greenhouse gases. So these greenhouse gases, like carbon dioxide, like water vapor, methane, they are transparent to the incoming solar radiation. मतलब वो उसको absorb नहीं करे, they allow them to pass, but they are opaque to the outgoing terrestrial radiation, outgoing radiation from the Earth. I'm repeating the statement. Greenhouse gases like carbon dioxide, like water vapor, methane, they are transparent to the high energy incoming solar radiation. वो pass करती है, वो absorb नहीं करती, interact नहीं करती, but they are opaque. They are opaque to the outgoing terrestrial, rocky terrestrial radiation. तो वो उसको absorb करती है. This is high energy short wave radiation that is coming from sun. They are transparent, they are doing nothing, but they are opaque to the energy that is coming from the earth. So earth जो energy दे रहा है, जो sun की energy earth ने absorb की थी, जो earth surface वो energy दे रहा है, greenhouse gas उसको absorb कर ले. A perfect example of greenhouse gas would be your car in a hot sun. What is the most heated? As you move, you'll see it's very hot, but सबसे ज़्यादा heat क्या होता है? Seat, the steering. Because the surface, right? It's not the atmosphere that gets heated. It is the surface that is getting heated. And from the surface, there is radiation of the heat. समझ आया? इसी को temperate region में क्या करते हैं? In the temperate region, in the colder, in the higher latitude, there is a greenhouse gas. There is a greenhouse. They make a greenhouse, a transparent sun glass का house बना देते. उसके अंदर plants रखते हैं. They keep the plants in the transparent glass house, and they call it as greenhouse gas effect वाला. They use that thing. तो transparent glass रख दिया, उसके अंदर plants रख दिए, तो जितना भी sun का आएगा, वो वापस उससे heat होगा surface से heat होगे, energy आएगी, फिर वो plants वो energy लेंगे. Otherwise, वो plants वहाँ पे survive नहीं कर सकते. तो glass house, greenhouse, this is the greenhouse gas effect that your earth also does. So this is how your troposphere gets heated. Troposphere gets heated like this. The other way in which, तो क्या कर रहे थे? Heating of Earth's atmosphere. How does the atmosphere get heated? The atmosphere and the greenhouse gases in the atmosphere are transparent to the high energy incoming solar radiation, but they are opaque to the outgoing terrestrial radiation. So that is how the temperature reduces as you move away from the heating source. In stratosphere, there is a very special gas called as ozone. Okay, ozone does what? Ozone gas है. तो ozone gas की speciality है. Ozone gas की क्या speciality है? वो direct UV rays को ले सकते हैं. It can directly take the UV rays. As it can directly take the UV rays, it can be absorbing the heat from the UV rays. So what happens in the stratosphere? What becomes the heating source? This becomes my heating source. So as you move away from the heating source, temperature reduces. क्या troposphere नहीं heat करता? Troposphere भी heating करता है, but इतना important नहीं. ज़्यादा important factor क्या होता है? So what is happening? The temperature is increasing as you increase in the stratosphere. So what is happening in stratosphere? The temperature increases with the increase in the height. What is happening in the troposphere? The temperature reduces with the increase in the height. ठीक है, तो आपको दो चीजें लिखनी है, ग्रीन हाउस गैस एंड दिस. हमने क्या लिखा? हीटिंग mechanism of the earth and the earth's surface. Write the first one. First point. Composition same होती है. हाँ हाँ हाँ. नियरली सेम होती है। एक तो वो बात है, जब हम बोलते हैं ओजोन, तो ओजोन का एक्यूमुलेशन क्या है? अगर मैं सेंटीमीटर में बात करूं तो 5 सेंटीमीटर, 3 सेंटीमीटर। क्यों ओजोन ज्यादा है? इट इज वाई बिकॉज योर द ओजोन इज, इट्स लाइक ऑक्सीजन, ठीक है? द ऑक्सीजन मॉलिक्यूल इज इंटरेक्टिंग विद द यूवी, इट गेट्स स्प्लिट। फिर ऑक्सीजन एटम रहेगा और एक ऑक्सीजन रहेगा, फिर ये ऑक्सीजन एटम अनस्टेबल है, तो ये ऑक्सीजन के साथ दूसरे ऑक्सीजन गैस के साथ मिलेगा और O3 देगा। तो एक साइकिल होती है, द साइकिल इज व्हाट? O प्लस O2 गिविंग मी O3, ठीक है? फिर ये भी बहुत अनस्टेबल है, तो ये भी टूट जाता है, ये वापस से O प्लस O2 देता है, ये चलता रहता है, चलता रहता है, चलता रहता है। यहाँ पे आप देखोगे जैसे स्ट्रेटोस्फीयर चालू हो रहा है, लुक एट, जहां से स्ट्रेटोस्फीयर चालू हो रहा है वहीं पे सबसे ज्यादा आपका O3 का कॉन्सेंट्रेशन नहीं है, ओजोन लेयर का कॉन्सेंट्रेशन थोड़ा ऊपर है। क्योंकि यहाँ पे क्यों नहीं है इतना? क्योंकि यहाँ पे टूटता है, बनता है, टूटता है, बनता है, टूटता है, बनता है। यहाँ पे बस वो एक्यूमुलेट होता जाता है थोड़ा बहुत। क्यों ऐसा हो रहा है? बिकॉज ऑक्सीजन इंटरैक्ट कर रहा है सन के साथ और स्प्लिट होता जाता है, स्प्लिट होता जाता है, बनता जाता है। नीचे तक, नीचे से ज्यादा एनर्जी आ रही है, आपकी टेरेस्ट्रियल भी आ रही है, इसलिए वो ऑक्सीजन ओजोन एक्यूमुलेट नहीं हो पाता। ऊपर ओजोन एक्यूमुलेट हो जाता, फिर भी ऊपर थोड़ा बहुत स्टेबल होता है, नीचे वो टूटता जाता है, बनता जाता है, टूटता जाता है, बनता जाता है। डोंट वी हैव ओजोन इन ट्रोपोस्फियर? वी हैव ओजोन इन ट्रोपोस्फियर ऑल्सो। एक होती है गुड ओजोन, एक होती है बैड ओजोन। हमारे यहाँ पे ट्रोपोस्फियर में भी ओजोन होती है, वो बैड ओजोन होती है, पोल्यूटेंट होती है। स्ट्रेटोस्फियर में वो उसका रोल बदल जाता है, इसलिए वो गुड हो जाता है, ठीक है? तो हुँ? हाँ, ओवरऑल कंपोजिशन, the overall composition of the gases, elements ना बोलो, gases बोलो, the overall composition of the gases। अभी के लिए 80 किलोमीटर तक होमोस्फीयर समझो, उसके ऊपर आप हेट्रोस्फीयर समझो। जब आप होमोस्फीयर बोल रहे हो तो नियरली सेम रहता है, बस एक कुछ सेंटीमीटर की लेयर हो जाती है आपकी ओजोन की, कहाँ पे? स्ट्रेटोस्फीयर पे, वेरी स्मॉल सेंटीमीटर। नीचे क्यों नहीं एक्यूमुलेट हो रही है? क्योंकि नीचे अनस्टेबल है, टूट रहा है, बन रहा है, टूट रहा है, बन रहा है। ऊपर क्यों एक्यूमुलेट हो रही है उसको समझते हैं, लेट अंडरस्टैंड दिस आगे। अभी के लिए ग्रीन हाउस गैसेस समझना ज्यादा इंपॉर्टेंट, विल अंडरस्टैंड दैट ऑल्सो। यस, यस, ओजोन इज अ ग्रीन हाउस गैस ऑल्सो, एंड ओजोन ऑल्सो ट्रैप्स द डायरेक्ट सोलर रेडिएशन। ओजोन दोनों करता है, ओजोन नीचे से भी हीट को एब्जॉर्ब करता है, ओजोन ऊपर से भी हीट को एब्जॉर्ब करता है, राइट? इट डज बोथ द थिंग्स। ओके, प्लीज राइट, वेयर आर वी? Yeah, the layering on the basis of temperature pattern you wrote, the heating and cooling mechanism लिखा हो? हाँ, the heating mechanism of the earth. First point, atmosphere that surrounds the earth's surface. Atmosphere that surrounds the earth's surface is heated in two ways. In two ways. First, absorption of UV rays. Absorption of UV rays. Absorption of UV rays by the ozone. Absorption of UV rays by the ozone layer in stratosphere. In stratosphere. Second, absorption of long wave radiation from the earth's surface, by greenhouse gas, Do you remember the spectrum, electromagnetic spectrum? क्या होता है? फर्स्ट बोल रहे हो, याद है, बताओ फिर। गामा रेस, देन एक्स रेस, देन यूवी रेस, देन visible rays, then infrared, then micro, then I talk about this. ठीक है, क्या हो रहा है? वेवलेंथ इज इंक्रीजिंग रिड्यूसिंग। गामा से रेडियो की तरफ जा रहे हो, वेवलेंथ इज इंक्रीजिंग रिड्यूसिंग, दोनों ही बोल रहे हो। वेवलेंथ इज increasing, frequency is reducing, the intensity is, the energy is reducing, so wavelength is increasing. So what is more, what is having more wavelength, the visible or infrared? Infrared is having high wavelength, ठीक है। What is having less wavelength is visible. Why am I telling this is your atmosphere. In the atmosphere you have greenhouse gas. Now you know that sun, it is transparent to the incoming solar radiation. It is transparent to short wave. I'm using some word, short wave solar radiation. And this short wave solar radiation is absorbed by Earth's surface. Now the Earth's surface radiates certain waves. ये waves कौन सी होती है? Infrared. This wave is infrared wave, which is longer wavelength as compared to visible. Visible के comparison में infrared ज्यादा है। तो ये greenhouse gas क्या करती है? They are opaque to the long wave infrared terrestrial radiation. They are transparent to short wave solar radiation. समझ आ रहा है ये स्टेटमेंट? वही लिखना है आगे। क्या लिखा था आपने? By the greenhouse gas. लिखो long wave terrestrial radiation. Long wave terrestrial radiation. In bracket you can write infrared radiation. आप समझ आ रहा है क्यों लॉन्ग वेव कह रहे हैं? एनसीईआरटी में जो नहीं समझ आ रहा था, लॉन्ग वेव का इसलिए मतलब है किससे कंपेयर कर रहे हैं? सोलर रेडिएशन से, जो कि शॉर्ट वेव। ठीक है, लिख लो, यही लिख लो। नेक्स्ट पॉइंट, ग्रीन हाउस गैसेस, यहाँ पे ब्रैकेट में ना इंफ्रारेड लिखना था, जो आपने डिलीट किया ना, क्योंकि वो इंफ्रारेड लिखना था ब्रैकेट में। लिखो नेक्स्ट पॉइंट, एब्जॉर्प्शन ऑफ, अच्छा, ग्रीन हाउस गैसेस आर ट्रांसपेरेंट। जो पहले पॉइंट बोला वो ये पॉइंट बोला, व्हाट वाज द पॉइंट दैट आई सेड? ग्रीन हाउस गैसेस किसको एब्जॉर्ब करिए? लॉन्ग वेव टेरेस्ट्रियल रेडिएशन, इन ब्रैकेट यू हैड राइट इंफ्रारेड, लॉन्ग वेव टेरेस्ट्रियल रेडिएशन ब्रैकेट में इंफ्रारेड लिखो। नेक्स्ट पॉइंट लिख रहे हैं, ग्रीन हाउस गैसेस आर ट्रांसपेरेंट टू short wave incoming solar radiation, short wave incoming solar radiation, but are opaque to outgoing terrestrial radiation. This is greenhouse gas effect. ठीक है, क्या लिखा? ये लिखा। अब शुरू से देखते हैं लिखा क्या। We wrote that atmosphere is heated by two ways. One is the ozone that is directly absorbing the solar radiation. Second, it is getting heated by long wave terrestrial radiation, infrared radiation. क्या लिखा उसके बाद? Greenhouse gases are transparent to incoming solar radiation, but they are opaque to outgoing terrestrial radiation. Outgoing terrestrial radiation कौन सी है? Infrared, इसलिए long wave। आ रही कौन सी है? Visible वाली, इसलिए short wave। UV, U और V दोनों आती है सन से, UV रेज आती है, that is what is happening। UV, ultraviolet और visible, ठीक, लिखो द लोअर एटमॉस्फेयर, पर हीट होता कौन से प्रोसेस से है वो लिख रहे हैं। द लोअर एटमॉस्फेयर, द लोअर एटमॉस्फेयर gets heated, the lower atmosphere gets heated through the process of conduction, convection and advection. Advection, conduction, convection and advection. इसका मतलब समझता है? The atmosphere is getting heated through three processes: conduction, advection and convection. क्या मतलब है इसका? How does the atmosphere get heated? If you just imagine yourself, this is a what? This is a pan. ठीक है, a steel pan. You are boiling the water. ठीक है, स्टील हैंडल था, तो स्टील हैंडल भी गर्म होगा. Why is it happening? वहां पे तो मैं हीट ही नहीं करी, यहाँ पे गैस हो रहा है, यहाँ पे कैसे हीट हो गया? Through conduction. Why? That something is in contact with a hot surface will get heated. So your atmosphere which is in the contact with the hot surface gets heated. This is conduction. The second can be convection. Convection is some movement is inward. Like how does the water get heated? Through the process of convection. Right? There is the hot water starts rising, the cold water goes going. You can see this, that is happening. The hot water starts rising, the cold water goes down. There is some movement and there is overall heating of the water. What do you say? This has the convection. Atmosphere में भी क्या हो रहा है? The warm air starts rising, it mixes with the cold air and the whole of the atmosphere gets heating. That is your convection. And what is advection? This was convection is vertical movement, advection is horizontal. So atmosphere gets heated through the process of conduction, convection, advection. Is it fine? तो ये processes हैं. अगर greenhouse gas नहीं होता, if there would have been no greenhouse gases in the Earth's surface, then what would have happened? Here, without the greenhouse gases, the Earth would have been too cold. It would have been very, very cold to support life. It is this greenhouse gases that traps the heat. It is this carbon dioxide that traps the heat. If there would have been no greenhouse gases, it would have been too cold to support life. Okay? Without greenhouse gases, the average temperature would have been -2 degrees Fahrenheit. Right now, it is about what? 57 degrees Fahrenheit. If I talk about in average term, it is about 15 degrees Celsius. It would have been too cold to even support life. So greenhouse gases के कारण हमारी life. तो आपको greenhouse gas effect समझा? ठीक है? This was the first question asked to me in my interview, final interview. First question: what is a greenhouse gas? What is a greenhouse gas effect? I think I have not told you the interview story. Interview story was like this. We were going in the hall and I was the second last to go before the lunch. There are two slots. One is pre-lunch, the other is post-lunch. Pre-lunch starts somewhere at 9. It ends over at 2 o'clock, 1:30, 2 o'clock. The second one starts somewhere at 2:30 and then ends at 5 o'clock. 2019. This is 2019. 2020, 1920 wala, my interview was on 18th Feb 2020. Just before, 1 month before COVID. And COVID happened and then there was stall. पहली बार interviews को 2 हिस्सों में लिया था. That was because of COVID. So some pre-COVID lockdown and some post-COVID lockdown. So it was before the lunch, but second half, second last to go. I was second last to go, and that happens with me today also. I do that. I went inside. पहले तो ये कभी मत पूछना कौन सा बोर्ड है. In the hall, generally people ask कौन सा बोर्ड है, मेरा कौन सा बोर्ड है. They will always tell you wrong information. I got to know 3 names before I could actually see कि चौथा ही नाम था जिधर हम गए थे. तो कभी मत पूछना वहां पे जाके कौन सा बोर्ड है मेरा. You cannot do anything as it is. 2 घंटे में क्या ही कर लोगे, खुद को थोड़ी restructure कर लोगे. You cannot restructure yourself then. I'll just speak in English, right? Yeah. So I was second last to go. It was like 9:30 se started, 9 to 10 first candidate, 10 to 10:30, 10:30 to 11, then 11 to 11:30, something like this. It was going on. I went inside and there was something behind your photograph. You have to write your roll number also. You have to carry a photograph and you have to write your roll number, nothing else, only the roll number. And there's a direction that is given. You have to write like this. This should be your photograph, your face, and your name should be right here. I put my name above. I was not knowing कि बहुत strict होता है. I put my name above. It should be below. I put my name above. So as I went inside, I said, first thing that happened is, I said, good morning, sir. Sir said, good afternoon. I'm like, हाँ, मुझे time lapse है. So I said, good afternoon, sir. Said, sat down. I sat down and he turned the photograph. उधर भी directions पूरे नहीं थे. He looked at me and I said, ये क्या है? What is this? You should be more careful. That is what I heard. The first statement that I hear is, good morning, or good afternoon. The second I get is, second, you should be more careful. Just like your mother says, ढंग से काम किया करो. What subtle language. I sat down. The first question that I was asked is, what is the greenhouse gas? I answered. What is the greenhouse gas effect? I answered. The third question that was asked to me was, how will you make children of school going children from class 6 to class 10 to reduce the greenhouse gas? What kind of initiative drive will you have? Tell me 5 points. And मुझे 2 याद है. मुझे afforestation याद ही नहीं आया. I could have said afforestation. I just said we will promote them not to use private vehicles जैसे कि वो कर सकते थे 6 to 12th में. But to go through bus transport, that is one thing I'll do. Second, I said that we'll encourage them to be more careful with respect to electricity, switch off the light and switch on the line when it is important. And then I said, sir, I am able to recall only 2 points. And sir said, बस दूसरे को दे दी. ये अब मुझसे नहीं हो रही, बच्ची handle. ये बहुत हो गया. Now some other candidate, you handle. So then second, sir. So there were 5 people. Here the chairman, sir. Here there was 1 sir. Here there was 1 ma'am. There were 2 sirs here. So I was answering to the next one. There the answers were from my city, from my district, from my home state. So I could handle that in a fairly nice manner. Not the best one. The third candidate to ask me, the third person to ask me was a lady. She was asking me social-based questions, society-based questions, as in about my hobby, about my interaction with the old elderly people, about my interaction with the women, working women. She asked me one question. I had written in my hobby that what is your this thing? Hobby, I had written talking to working women. The first question she asked me was, what do you mean by working women? And then I realized, oh, it could be a blunder. And I said, ma'am, working women is any women. It does not mean those who are contributing economically. But the reason I have written as working women here is, so she said, oh, then it could be any women. Why have you written working women? So I said, ma'am, I have written working women. Why? Because there's a forum, online forum, where the working women, they share their economic issues, they share their work culture, they contribute to the how should the work culture could be improved. Therefore, I have written. But this is not to mean that only that women which contributes to economy is a working woman. So wahan se I could start picking up my interview, the social issues. And then there was 2 sirs who talked to me about the electoral reforms, talked to me about the terrorism in Pakistan. That is what they asked me. And I realized I could pick up my interview from the questions of social issues. So I could pick up my, and chairman sir was continuously looking at me, I was knowing, but I was looking at all the other, because while you're talking to someone, you look them more than looking everyone. So I was constantly talking to that ma'am. I got decent marks, not very good marks. I got around 172 out of 275. So little above average. The very good score is 200. I got the average score is 155, 160. It was above average, 172. So what I thought was bad interview, तब तक तो bad ही लग रहा था कि आपने क्या गलती कर दी. Morning का afternoon का morning, afternoon का morning. हाँ, अभी भी गलती होता है. I get time lapse. I forget about the timing of the class also. There are times where I can extend the class for half an hour and then realize, oh, the class, I have exceeded the class. आप लोग तो बता देते हो. ठीक है? So that is the thing. What you think went bad is not always bad. What you think was too good is not always too good. So I was asked this greenhouse gas, the greenhouse gas effect, and I could answer only 2 points situation based. But then think, what they actually probably try to check is your attitude. Whether are you able to lose your calm? Whether are you able to stand no matter what? And ठीक है ये UPSC है. Even in life, I always say this to myself. When the life has to take revenge from you, इतना खुश क्यों चल रहे हो? अभी इधर आओ. When the life has to take that, it'll have its chances. The point is, we have had examples of people fighting cancers. We have had examples of people coming up from the lowest ebb from where they were. Yuvraj Singh, okay? We have had examples. Point is, and it is quite obvious that probably we will also have that. Okay? There would be moments, probably not now, later, or probably some of us are facing now also. We will have those moments. And let me tell you very honestly, you cannot prepare yourself on the D-Day. D-Day पे शक्ति नहीं आ जाएगी कि अलग इंसान बन जाओगे. You will have to start preparing yourself from now. You have to start now. We all are adults. Okay? Probably we'll be mothers and fathers in next 5-10 years. Okay? We'll have responsibilities on our shoulders. The time is now to restructure yourself, to have an attitudinal change, to move forward. The time is now. It's high time we start doing it. We start realizing. Okay? So this is something that I just shared a story about the greenhouse gas, about the greenhouse gas effect. Let's move on. Okay? I'll tell you about your questions, जो भी मन में है, later. Fine. So without the greenhouse gas, it would have been very, very cold. Because of the greenhouse gases, we are able to survive. Come to geography. लिखो ये diagram बनाओ. Make this diagram of greenhouse gas. Make the diagram of greenhouse gas. अरे सो गए क्या? बनाओ. कुंदन, डियाना, सुमांता, प्रिया, कार्तिकेय, टोकाराम. दिख रहा है? कितनी स्पार्क्स? जल्दी बनाओ. हाँ, do it. Let me start. Let me mark it for you. The first one is solar radiation passes through clear atmosphere. Second, most radiation is absorbed by Earth's surface and warms it. The third is some solar radiation is reflected by the Earth and its atmosphere. Some of the infrared rays, some of the Earth's radiation is getting reflected. Okay, clouds say. Anybody knows what is this term called? The solar radiation getting reflected by the atmosphere, by the clouds, by the ice caps. Albedo. So this is albedo. By the Earth and the atmosphere, some wave get reflected. The fourth one is some of the infrared rays pass through the atmosphere. कुछ infrared rays sun की भी होती है. Sun की जो light आती है वो 3 spectrum में आती है. U, V and I. Okay. Sun का कुछ of the infrared rays, they're absorbed by the atmosphere. Some are re-emitted, and the effect is to warm the Earth's surface. Okay. The infrared radiation. This is the fourth one. And this is the infrared radiation is emitted from the Earth's surface. Infrared radiation is emitted from the Earth's surface. They are passed through Earth's surface. They are passed through atmosphere. This is the fifth one. So labeling karna in that order. 1, 2, 3, 4, 5. Make the diagram. If you have doubts, we'll see the doubt notes. स्माइलिंग थोड़ी सन बनाना है, लेबलिंग करनी है, लेबल करो स्माइलिंग सन। लेबल अरे पूरा लिखो ना। सोलर रेडिएशन पासिंग थ्रू क्लियर एटमॉस्फेयर। सेकंड, most radiation is absorbed by the earth's surface. दिख रहा है आप? सेकंड, and warms it. Third is some solar radiation is reflected by the earth and its atmosphere, albedo, कुछ reflect कर रही है sun rays. Fourth is some of the infrared passes through the. Fourth is earth ने किया infrared rate को emit. टैब में डाल दिया, बहुत अच्छी बात है, पर प्रैक्टिस भी करो। एग्जाम में थोड़ी कॉपी पेस्ट होगा, एग्जाम में बनाना है हाथ से। डन? नो, टेक योर टाइम। Good. Greenhouse gas is a natural effect. Why are we so concerned? Because we are increasing the greenhouse gas. As we are increasing the greenhouse gas, what is happening? There is warming. As there is warming, there is melting of ice caps. As there is melting of ice caps, the carbon dioxide trapped in the ice caps gets released. More carbon dioxide, more warming, more melting of ice sheets, more. It is said that as per IPCC, still today, 83% of CO2 is being absorbed by your ocean. You release whatever additional amount, the CO2 is still being absorbed by the ocean, but it has repercussions. There is in warming of the oceans, there is sea level rise, there is coastal erosion, there is coastal submergence. As the ocean is warming, there are more of cyclones coming. As the ocean is warming, there is increase in the temperature, causing problem to your biota, biological life forms, fishes, marine organisms. Do we take into consideration the effect of those oceans? No, we are not bothered. आज भी स्टडीज जो होती है वो ज्यादातर लैंड एनिमल्स, लैंड प्लांट्स पे होती है. Should we not be concerned? We should be concerned. Yes, कोरल ब्लीचिंग हो जाती है. और कौन करेगा? फ्लोरा ही तो मेंटेन नहीं होगा, ज्यादा कार्बन डाइऑक्साइड आएगा. There is more of carbon dioxide, right? As the ocean warms, ocean can absorb less amount of O2. Oxygen gets dissolved more in the cold water. If the ocean is warming, the O2 levels decreases. As the O2 level decreases, there would be less of DO, dissolved oxygen in the oceans. That affects the life form. With global warming, there is dissolution of calcium shells of your crabs, dissolution of the calcium shell of the calcareous animals. Because of warming, there is effect on the reproduction cycle of the organisms. Because of warming, there is coral bleaching. So double effect हो रहा है, run away effect को कहते हो आप. Yes, yes. ब्लू कार्बन चल रहा है ये फॉर्म. यस, चल रहा है कि आप ओशन में अगर बढ़ा दो, अगर आप लाइफ फॉर्म्स को बढ़ा सको या प्रिजर्व कर सको, तो आप फिर भी सस्टेन कर पाओगे. ब्लू कार्बन, ब्लू कार्बन तो कब से चल रहा है, 2014 से न्यूज पे चल रहा है ब्लू कार्बन, ठीक है. They absorb the carbon dioxide by the oceans and the ocean organisms, the blue carbon, right? Carbon sequestration is a term used, anything that absorbs the carbon dioxide from the atmosphere, anything that is carbon sequestration, plants, wetlands, greenlands, etc. Is it fine? So this is what, this is your greenhouse gas. First, soil radiation passes through clear atmosphere. Most radiation is absorbed by the Earth's surface, which warms it. Some solar radiation is reflected by the Earth and the atmosphere, albedo. Most wali surface se warm karegi. The Earth's surface absorbs the heat and emits infrared radiation. The infrared radiation is absorbed by the atmosphere. This is long wave. Solar radiation is short wave. This one is absorbed, and then that heats, the redistributes your heat. This is your greenhouse gas. What are greenhouse gases? Likho. What are greenhouse gases? Carbon dioxide, carbon dioxide, methane, methane, nitrous oxide, nitrous oxide, carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, HFC, hydrofluorocarbon, PFC, perfluorocarbon, perfluorocarbon, sulfur hexafluoride, sulfur hexafluoride, nitrogen trifluoride, nitrogen trifluoride, ozone and HCFC, ozone and HCFC. HFC भी है, HCFC भी है, PFC भी है, SF6 भी है, CO2, मीथेन और ओजोन, etc. ठीक है? Okay. Just 1 second. Online class, are you with me? Yogesh, Diana, Kundan, Sumanta, Karthike, Priya, and others. Okay, so this is what? This is your greenhouse gas. Now you understand how has your Earth's atmosphere warmed? There was a question that was asked in 2023. In 2023, this year prelims. In case you remember, let me see if I have that question with me. In 2023, let me just search that question for you. Green infrared radiation. You remember? Anybody of you have given the examination? Yeah. What are the statements? The statement was, the first statement, with reference to Earth's atmosphere, which of the following is correct? First, the amount of insolation, that is received at the equator is roughly 10 times the insolation received at the poles. So it is saying the insolation that you receive at the equator is 10 times more than that at the poles, than that of the poles. This is the first statement. Insolation received at the equator is 10 times more than that at the poles. Second, infrared radiation constitute two-thirds of the insolation. Two-thirds of the insolation is your infrared radiation. जितना भी insolation आता है उसमें से 2/3 जो आता है वो infrared पे आता है. Second step. The third statement is infrared radiations is largely absorbed by the water vapor that is concentrated in the lower atmosphere. It says infrared radiations are largely absorbed by the water vapor that is mostly concentrated in the lower atmosphere. And the fourth statement is infrared radiations are part of visible spectrum of the electromagnetic waves of solar radiation. So infrared is a part of visible spectrum of the electromagnetic radiation. Okay. These are the 4 questions. Which of the following is correct? First, that the equator receives 10 times the insolation that of the poles. First. Second is infrared, 2/3 of the solar insolation is your infrared radiation. Third, the infrared radiation is absorbed by the water vapor, which is concentrated in the lower atmosphere. And the fourth one is that infrared is a part of visible spectrum. How many for A? How many for A? A B C D है, यही है बस. A, B and C and D. इसमें नहीं था only 1, only 2. Question number 62. ठीक है. How many for A? 1, 2, 3, 4, 5, 6, 7, 8. How many for B? How many for C? 1, 2, 3, 4, 5, 6, 7, 8. How many for D? सबसे गलत तो D है. इंफ्रारेड अलग है, विजिबल अलग है. अब B और C और D, A पे बात करते हैं. A is says, do we receive more insolation at equator? Yes. Do we receive 10 times more than that of the poles? No. So A is wrong. Still A और A, B, A, मतलब D तो हटा दिया, A, B, C में से ऑर्डर किया तो मतलब टिक किया तो still better है. How many said B? Nobody said B, right? This is not B. The answer is C. Infrared radiation जो कि sun से, जो कि earth से re-emit हो रही है. The absorption, the re-emitted in the form of infrared. This is absorbed by the greenhouse gas. This is nothing but water vapor. So the answer is what? C. 2/3 of the insolation is not, sun is not, 2/3 is not infrared. You say U, V and I. This is what sun gives me. Only around 27% is infrared. Okay. Rest U and V are about 63%. तो इंफ्रारेड बहुत कम है. अगर इंफ्रारेड बहुत ज्यादा होता तो ग्रीन हाउस गैस अलग तरीके से काम करता, राइट? इंफ्रारेड को तो एब्जॉर्ब कर सकती है ग्रीन हाउस गैस, राइट? जो अर्थ से आ रही है वो इंफ्रारेड ही है. इट इज नॉट मोर ऑफ इंफ्रारेड, इट इज मोर ऑफ यू एंड अल्ट्रा विजिबल, अल्ट्रावायलेट एंड विजिबल, राइट? सो हाँ, आंसर इज व्हाट? Nobody online class note C, not answer is C. Answer is C. Answer is was C. This was something that was geography per se, climate. ठीक है, climate से ही पूछा है, ग्रीन हाउस गैस से ही पूछा है, राइट? ओके, मूविंग ऑन. तो ग्रीन हाउस गैस वाला ही था. क्या डायरेक्टली क्वेश्चन आया है ग्रीन हाउस गैस पे? नहीं, अप्लाइड है. बट क्या could I have solved it? Yes, you did this right in your class. In your, how many gave the examination and attempted this question? हुआ था सही? नहीं हुआ. What about others? याद भी नहीं है. ठीक है, क्या पूछ रहे हो? Okay, fine. This is about your greenhouse gas. Give the next heading. Give the next heading. The layering of the atmosphere. The layering of the atmosphere on the basis of temperature pattern. अब detail में पढ़ेंगे. Layering of the atmosphere on the basis of temperature pattern. पहले हमने सिर्फ roughly देखा था. Greenhouse gas देख लिया, and now we will deal it in detail. The first one, troposphere. The first one is troposphere. First point, the temperature reduces. The temperature reduces with the increase in height. Temperature reduces with the increase in height. As troposphere is heated, from below. Heated from below. In bracket, you can write outgoing long wave, outgoing long wave terrestrial radiation. Outgoing long wave terrestrial radiation. This is the Earth's surface. This is your troposphere. This is, let's say, pole. This is your equator. The temperature is reducing with the increase in the height. Temperature reduces with the increase in the height because it is getting heated from the Earth's surface below and the long wave terrestrial radiation. Okay. The rate of cooling is 1 degree Celsius, per 165 meter. The rate of cooling is 1 degree Celsius per 165 meter, या तो फिर और 6.4 degree Celsius per kilometer. 6.4 degree Celsius per kilometer. This is called as normal lapse rate. This is called as what? This is called as normal lapse. ठीक है. In normal lapse rate average है. Summers may it will be different, winters may it will be different. This is an average. 6.4 degrees Celsius per 1 kilometer. Third point, the height of troposphere is 8 kilometer at poles, and 18 kilometer at equator, The average height is 13 kilometers. 13 kilometers. Okay. Write this point. Thickness is greater at equator. The thickness of troposphere is greater at the equator. है ना? 18 किलोमीटर तक है, यहाँ तो 8 किलोमीटर है. What is the reason? Direct solar radiation. Shape of the earth. तो बल जाए तो ये भी बल हो जाएगा. That was a very interesting insight. Gravity is more at poles. Rotation. Centripetal force. Wow. Centrifugal, centripetal, gravity, shape. क्या बात है. Vegetation कैसे? अरे कौन ज्यादा गर्म है? This or this? Equator, direct solar radiation नहीं बोलो, heat बोलो. ठीक है? तो heat is transported up to. अच्छा पहले तो ये बताओ, where is troposphere? What does troposphere mean? What does troposphere mean? What is the word troposphere mean? What is the word troposphere means? Tropos का क्या मतलब होता है? Tropos. What does tropos means? It means turning away. What is happening in troposphere? The air rises, and after this it cannot rise, it turns away. It starts turning away. The air rises, it starts turning away. Air rises and it starts turning away. यहाँ पे इसलिए mixing भी अच्छी होती है. There's much of mixing because the same air is mixing, it's getting mixed. The tropos means turning away. So it marks the maximum limit up to which your air packet can travel, and then it starts turning away. ऐसा क्यों हो रहा है? ट्रोपोस्फियर में से कुछ स्पेशल नहीं है. हम लोगों ने नाम ट्रोपोस्फियर को स्पेसिस पे दिया है. You observe the air packet, it was rising, it could not rise beyond a point, it starts moving, it starts turning. What do you call this layer as? You call this layer as troposphere. Why? Because it means turning away. So यहाँ पे ज़्यादा heat है. There is more of heat. There is less of heat here. So obviously The air to rise up and cool and turn away will require much of the height, will require much of the thickness. But here the air will not have to rise as much to actually cool itself. Already air is cold. So it is not to deal with, it has to deal with heat, right? So the thickness is greater at ठीक है, हाँ तो वो ठंडे होते हैं. Yes, therefore they are cold. Correct. Right? Please write. The thickness is greater. The thickness of troposphere is greater at equator because heat is transported. Heat is transported to a greater height. To a greater height. Yes, man. Heat is transported to a greater height by convectional currents. By convectional air currents. ठीक है, हीट और दूर तक जाएगी और फिर उसके बाद ही टर्निंग होगी. ठीक है, लिखो. The air packet rises, an air packet rises up to great height. Up to great height before it starts turning away. Troposphere, इसी में लिखें, troposphere is derived from the word tropos, T-R-O-P-O-S, tropos, which means turn away, which means turn away. ठीक है, bracket close, right? Troposphere is also called as, troposphere is also called as the convective region. It is also called as convective. Convective region, C-O-N-V-E-C-T-I-V, convective region, since all the convection stops at tropopause. Stops at tropopause. You understand these terms, right? Convection, convectional air current. अभी देखा, conduction is transfer of heat by in being close contact. Convection is transport of the heat by vertical movement. Convective air current कहाँ तक जा सकते हैं? Tropos तक, troposphere तक. उसके बाद क्या होगा? They will start turning away. There is more heat at the equator. So the convective current goes up to a higher height up at the equator. Is it fine? So why is the height of troposphere more at equator and less at poles? The next one. Now listen this. If this is your surface equator, this is your pole, this is my troposphere, 8 kilometer, 18 kilometer. Tell me one thing. Which place will be cooler? Place A. This is troposphere, tropopause, okay? Tropopause. Place A or place B? Which will be cooler? How many believe A will be cooler? How many believe A will be cooler? Okay, not visible. This is A. This is. How many believe A will be cooler? Online class. How many believe B will be cooler? Why B will be cooler? Because there's more of height, 18 kilometer. So, and what I said, the temperature falls by 6.5 degrees Celsius per 1 kilometer. If you multiply by 18 or you multiply by, the difference is what? 6. If you multiply by 18 or you multiply by 8, in दोनों के बीच में cooling is at this rate. So the difference is, the difference between the pole and equator is 10, right? ये यहाँ पे 8 है, यहाँ पे 18 तक है, तो यानी 68 डिग्री सेल्सियस का टेम्परेचर का डिफरेंस आ जाएगा इफ पर किलोमीटर 6.5 65. कभी भी इक्वेटर और पोल पे इतना टेम्परेचर डिफरेंस तो नहीं हो सकता. Probably equator would be warmest in, let's say, at 45 degrees Celsius. Even if it is warmest at 45 degrees Celsius, इतना होता नहीं है. And this is, let's say, 0 degrees Celsius. Then also the air above this will always be cooler. समझ आ रहा है? Because ज़्यादा height है. There's more of height. There's less of height. So which is cooler? This is cooler. Because there's difference in the height. आप सोचोगे अरे ये तो गर्म है, पर इतना थोड़ी गर्म है कि 10 किलोमीटर का भी डिफरेंस को कैच कर ले, right? So write this. The troposphere experiences fall in temperature. The troposphere experiences fall in temperature with the increase in height. With the increase in height. The temperature is minus 80 degrees Celsius. The temperature is minus 80 degrees Celsius. The temperature is minus 80 degrees Celsius at the equator. At tropopause. While the temperature is minus 45 degrees Celsius at the poles at the tropopause. तो tropopause, I have one question. तो बताना tropopause पे कौन ज्यादा ठंडा है, air above the equator or air above the poles? Air above the equator is colder and the air above the pole at the tropopause is warmer. If I say in geography, you have temperature is inversely proportional to pressure. Temperature is inversely proportional to pressure. So where would be high pressure at the tropopause? At point B or at point A? If I say temperature is inversely proportional to pressure, where would be the high pressure be? At the tropopause. At the tropopause, high pressure कहाँ रहेगा? At point B or at point A? जहाँ पे टेम्परेचर ज्यादा रहेगा वहां पे प्रेशर कम रहेगा. तो टेम्परेचर कौन सा ज्यादा है, पोल्स पे की इक्वेटर पे? minus 80 की minus 45, which is माइनस. कहाँ टेम्परेचर ज्यादा, इक्वेटर पे की पोल्स पे? ट्रोपोपॉज पे टेम्परेचर ज्यादा कहाँ है? पोल्स पे. तो प्रेशर कम कहाँ होगा? पोल्स पे. तो हियर व्हाट यू हैव, नाउ लिसन, एट द पोल्स, geography, this is surface, let's say this is equator, this is poles, this is your tropopause. surface पे equator पे कैसा प्रेशर होता है? लो प्रेशर. surface पे पोल पे कैसा प्रेशर होता है? हाई प्रेशर. इक्वेटर पे ट्रोपोपॉज पे कैसा प्रेशर होता है? हाई प्रेशर. पोल्स पे ट्रोपोपॉज पे कैसा प्रेशर होता है? लो. समझ आ रहा है? Are you getting it? The turning away. Air always moves from high pressure to low pressure. Air always moves from high pressure to low pressure. Vertical air currents कैसे होते हैं? Low pressure to high pressure. Vertical air currents कैसे होते हैं? Low pressure to high pressure. Can you see the mixing? Can you see the turning? समझ आ रहा है? तो ये बस इतना याद रखना अभी के लिए, इक्वेटर पे ट्रोपोपॉज पे क्या प्रेशर रहेगा, इक्वेटर पे ट्रोपोपॉज पे, अरे नीचे जो प्रेशर रहेगा उसका उल्टा सोचना, इक्वेटर पे ट्रोपोपॉज पे क्या प्रेशर है, हाई प्रेशर। पोल्स पे ट्रोपोपॉज पे क्या प्रेशर है, इक्वेटर पे ट्रोपोपॉज पे क्या प्रेशर है, हाई प्रेशर। ठीक है, अभी थोड़ा डीप हो गया ये, but then लिख लो, right? Just write this much. We'll see this again. Meteorologically, online class, are you there? Meteorologically, this is the most significant layer. Meteorologically, this is the most significant layer. As the entire atmosphere, and nearly all the weather phenomena, like cyclones, rainfall, fog, hailstorm, are confined to this layer. Okay. Right, the next point. Above the troposphere, the temperature is constant. In tropopause. ठीक है, therefore tropopause acts as a lid, and it holds all the circulation, within tropopause. ठीक है, I think many of you will take time to absorb this fact कि हाँ, tropopause at the tropopause above the equator, what do you have? You have a high pressure. Tropopause at the poles, you have a low pressure. This is very important to understand now, because if I talk about upper tropospheric winds, when you hear the terms jet stream, when you hear the term Rossby wave, okay, it is very important to understand upper tropospheric wind. Upper tropospheric wind should move from equator to the poles, because at equator what you have? High pressure. At poles what you have? Low pressure. So if there is no other force, if there is only pressure gradient force, सिर्फ pressure को ही follow करे अगर, so it should move from equator to poles. But then there is all of other factors. इतना ही तबाह नहीं, इतने में ही तबाह नहीं होना है, और भी है, इसको पढ़ेंगे. ठीक है, लिखो, just like tropopause acts as a lid. लिखा, tropopause acts as a lid and holds all the circulation within the troposphere. So all the jet planes, aeroplanes fly in the tropopause, or in the lower stratosphere, Okay, so this is the first layer, troposphere. In the troposphere, you have, this is stratosphere. I said nearly all the weather activities are, averaging लिया मैंने 13 kilometer. All the clouds, nearly all the cyclone related things your precipitation, fog, they are confined here. So because the clouds are in the lower layer, what happens? The jet planes, they fly in the tropopause or in the lower stratosphere. जब के jet planes हैं, aeroplanes हैं, वो clouds के ऊपर रहते हैं, right? You can see the layer of the clouds from the planes. Why are they flying just above the troposphere? Why are they flying in the tropopause? Or why are they flying in the stratosphere? Because they want to avoid turbulence. अगर cloud आ गया तो turbulence होगा. They also want to save their fuel. सबसे ज़्यादा fuel cost होता है. The most costly is in the air. The air transport is the fuel. The aviation turbine fuel. So if there's not a lot of clouds, there will be disturbance. Otherwise, you can fly smoothly, so you can save the fuel also. So much of the jet planes, where do they fly? They fly in the tropopause or they fly in the lower stratosphere. Right. So this is about your troposphere. We'll deal with stratosphere and the other layers tomorrow. Stratosphere, thermosphere, exosphere, etc. There have been questions asked from this topic, from the greenhouse gas, from the layering of the atmosphere. They have asked the questions. We'll also deal with the questions tomorrow. Okay.